Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
And today we are beginning with distance formula. This is the last topic as per your textbook. So let's see how can we work on this. Distance formula, that is exercise 28, and we are going to break this into two parts. Alright. So for the first part, distance formula, what does it mean and what are you going to do in this exercise? So when you look on the graph, you will see a particular line A and B. Let's take this line. Coordinates of A are minus 2 by 2 and coordinates for B are 3 by 2. If I want to find the distance between A and B, okay, then I'll have to count the number of boxes between A and B. So starting from here, 0. This is going to be the first one because this is one distance. So 1, 2, 3, 4 and 5. So it was simple. So distance of AB is equal to 5 units. We know that already, right? But if there is a line which goes cross, then in that case you don't get straight boxes, and how will you count them? Alright, so first we will see how distance formula helps us to get the answer of AB as 5, and then we will use the same formula for all the different types of coordinates that are available in this exercise. So what is the distance formula? So distance formula, let's say if you are finding the distance between A and B, is x2 minus x1 square plus y2 minus y1 square under the root. If you apply this formula for any coordinates, automatically you will get the distance for that particular points. In this case, you had A as minus 2 by 2 and you had B as 3 by 2. Let's apply this over here and see whether it works or it doesn't work. So x2, okay, in this case, A will be called as x1 y1, B will be called as x2 y2. Is that clear? x1 y1, x2 y2. So x2 is 3 minus from the formula, and then x1 is minus 2 the whole square. Do you understand this? How did I substitute? First the x2 minus is from the formula and then this minus 2. Don't forget, otherwise you will mess up. Likewise y2 is 2 and y1 is also 2 the whole square under the root. So 3 plus 2 5. 5 square is 25. 2 minus 2 is 0, 0 square is any which way is 0. So I get root of 25, which becomes 5. Exactly what was the distance between A and B we got directly, and right now we got it using the formula. So you need to know how to apply the formula. It's very simple. Just take the points and apply it. Is that very clear? Will you be able to apply this formula? Yeah. x2 minus x1 plus y2 minus y1 each squares under the root. You have to remember that. Alright. Now couple of more things before we get into it. If you remember earlier in the coordinate geometry chapter, let's say if A is minus 2 by 2, we said 2 is called as abscissa and this 2 is called as ordinate. Basically abscissa is the x coordinate and ordinate is the y coordinate. Will you remember that? And one last thing you need to remember, let's say if the point lies on x axis anywhere, okay, if they say that the point is lying on x axis, then the coordinate of that point, we don't know the x coordinate. That can be anything. Right now I have plotted so you know, but from the textbook point of view they will not tell you, but you know the y coordinate for sure. X coordinate is not known, but y coordinate becomes 0. Likewise, if the point lies on y axis, then the y coordinate we don't know, so we call it as y, but the x coordinate for sure is 0. Alright, so I'm just writing it over here for our reference. If the point lies on x axis, then we call such a point as x comma 0, and if the point lies on y axis, we call it as 0 comma y, because this x is unknown but y coordinate is surely known, which becomes 0. So if the point lies on x axis, the ordinate is 0. If the point lies on y axis, the abscissa is 0. Will you remember this? This is very important. You will need this. Now where all are you going to apply distance formula in this chapter? For example, if they give you a triangle and 3 coordinates of the triangle, 2 by 1, 3 by 2 and 1 by minus 2. These are random points I have taken, and they say that prove that this is an isosceles triangle. How will you prove that? So obviously you will take AB ka distance, use distance formula, find the distance, find AC ka distance, find BC ka distance. If two sides are equal, automatically you will say since two sides are equal, it is an isosceles triangle. Are you getting it? That's how you're going to apply distance formula. One more example before we go ahead. Let's say if this is the diagram given to you A, B, C, D, and some coordinates are also given to you for A, B and C. And they say prove that this is a rectangle. How will you prove rectangle? So you will first find distance AB, distance DC, distance BC, distance AD. So 4 distances you will apply and find them out. If opposite sides are equal, you will say that it is a parallelogram. Remember, it is a parallelogram, but our target is rectangle. So then you will apply for the 5th time the distance formula and the 6th time to find AC and BD. Since AC and BD both are equal, the parallelogram becomes a rectangle. Do you understand it? So these are different ways where you will see distance formula being applicable. Very simple topic. Once you get into it, you will be easily going with a very smooth flow. So don't worry. Just remember the formula. Pause the video, memorize it once or twice, write it somewhere. If you are fine, if you got it correct, only then begin. Okay? x2 minus x1 the whole square plus y2 minus y1 the whole square under the root. Remember, the sign from the formula should come and then the sign from the coordinate. Don't mess up both the signs. Is that clear? Alright, let's go with small steps. I want everyone to pick up sum number 1 part 1, apply distance formula and get the distance between these 2 points. Come on, pause your video, try it and get me the answer. So you need to mention by distance formula. Whenever you are applying it, you are expected to mention this line by distance formula, and let's call this as A and B. So I will say distance AB is equal to, write the formula so you will learn it, and it's better always to write your formula so you never go wrong in the exam. So x2 minus x1 square plus y2 minus y1 square. What is your x2? That is 2. And what is your x1? So minus 3. Why are you all copying? Come on, pause. Go ahead on your own. Minus 6 the whole square under the root. So 2 plus 3 5 becomes 25. Minus 6 minus 12. Minus 12 square 144 under the root. So I get it as root 169. That is 13 units. So we have managed to get the distance between these 2 points as 13 units. Don't write centimeter or anything, just write units. Is that clear? How many of you have got this correct? Brilliant. If you got this, almost the entire exercise you are there, except for a few things here and there. Come on, let's apply it one more time with slightly difficult coordinates. So let's call them as A and B. Find the distance. So by distance formula, come on everyone, on your own without my help. So distance between AB, x2 minus x1 square, y2 minus y1 square. Let's apply it. So x2 is 0 minus root 3 plus 1 the whole square, and y2 is root 3 minus 1 the whole square under the root. Now you need to be little smart over here. How to work this out? Pay attention carefully. 0 minus. Now you don't open this minus sign, rather take this minus sign and square it. So when you take the minus sign and square it, what happens? It becomes plus. And then what will be left is root 3 plus 1 the whole square. Automatically things will become easier. Plus root 3 minus 1 the whole square under the root. Now open these brackets. So a square b square 2ab. Likewise a square b square minus 2ab. See, a, b minus 2 root 3 under the root. This gets cancelled. So 3 plus 1, 4 plus 4, 8. So root of 8 will be 2 root 2 units. How did I get this 2 root 2? You take factors of 8 and whatever common is there, you pull it out and uncommon stays inside. That's how we got 2 root 2. How many got this correct? Super. Great job guys and girls. Let's go ahead. Sum number 3. The distance is 5 between these 2 points. Find x. So once again I would want you to look at this particular formula. How many components are there? 5. What are these 5 components? One is the distance, then x2, x1, so 3, and y2, y1, so 5. Out of these 5 components, you will be provided with 4, and the 5th one you will have to find. So in this particular question, they have given you 1, 2, 3, and 4th. 4th is your distance given, but this y2 is missing. So you'll have to find y2 after applying the formula. Are you getting it? So out of 5 components, 4 always will be given to you. The 5th one they will always ask you to find it on your own. So let's apply it. So distance formula, let's call them AB. Please write over there always by distance formula. I'm not writing it. x2 minus x1, y2 minus y1 the whole square. So how much is the distance? Already given to us as 5. You can always take this root on the other side and square it. So your root is gone forever. Life becomes easier. x2 minus x1. So x2 is 0, x1 is 3, y2 is x minus 1. So I get 25 minus 3 square 9, x square plus 1 minus 2x. So I expect there is going to be a quadratic equation which we'll have to solve. So x square minus 2x, 9 plus 1 10, 25 coming on this side, so negative 15. You can do this and you should reach over here. Splitting the middle term, so for 15 it is going to be 5 plus 3. Am I right? 5 plus 3 gives me 2 and 15. So my final factors are going to be x common. So x minus 5 plus 3x minus 5. So my next step is going to be x minus 5, x plus 3 equals 0. I hope you know how to factorize. Once you factorize this, obviously x minus 5 is 0. So x becomes 5 or x becomes minus 3. We are very much aware how to go about with this, and that's your answer for x. So x was asked and we found two values of x. That means this point can be at two places and therefore the distance will be 5. For example, let me make it very clear to you. If I say b is over here and the distance is 5, this 3 by 2 can be somewhere else also 3 by something, where the distance can be 5 here, here or anywhere where it is 3 but yet the distance can be 5 probably. Therefore two answers they have given you in this case. Yeah, so don't get confused, it's correct. Now the real test. Point is lying on y-axis. Do you remember if the point lies on y-axis, what did I tell you? Think about it. Distance is 10 and 2 more components are given. So out of 5, you've been given only 1, 2 and 3. How will you solve? Because I said you need minimum 4. So this is the clue which is going to help you. You remember if the point lies on x-axis? Exactly, 0, no, x comma 0. If the point lies on y-axis, 0 comma x. So you say over here, point on y-axis, let it be a, 0 comma x. Let's call this b. So therefore distance AB is equal to x2 minus x1 square, y2 minus y1 square under the root. So what are the distance? 10. What is x2? So now here you can consider anything as x1 y1. Matlab you can take this x1 y1 or take this x1 y1. But you can't take this x1 and this y2. Okay, remember that. In any case, your answer remains the same whichever you take x1 y1. Alright. Always try and take the alphabet as the first number. Don't put it behind, otherwise you will get confused. So if I want to take this first, this has to be x2 y2. So 0 minus minus 8 the whole square and x minus 4. Try and keep this variable first. Okay, root I'm getting on the other side, so square, so I'll get 100. 8 square, so 64. This will be x square plus 16 minus 8x. Are you with me till here? So one more quadratic probably again. So x square minus 8x, 64, 70, 80. 100 comes on this side, so minus 20. Splitting the middle term, 10 2s are. So basically I will get x minus 10 and x plus 2 as 0. So therefore I can say x is equal to 10 or x is equal to minus 2. Both possibilities are there. But this time they never asked you x, they asked you the point. So you say therefore point A can be 0 comma x, that is 0 comma 10 or 0 comma minus 2. Both possibilities. Did you get it? Don't stop at x now, otherwise your 1 mark will be lost. You will have to go to this particular point and say that these are the possible points for a distance of 10 from B. Do you get it? This is a very important question because they can also give you from the point of view of x-axis. So put a star besides it and see to it you practice it well. Let's go with the next one, 6th. They say distance is root 10 and a particular point is this. Let's call this as B. and point A ordinate is twice of abscissa. Nothing is given over here, so now you'll have to convert this. Okay, so let abscissa be x, so ordinate will be twice of abscissa, that means 2x. So your point A will be x comma 2x. So we generated point A. Now can we apply the distance formula? I have given you the start. Ordinate twice of abscissa. So abscissa was smaller, I considered x. So ordinate becomes 2 times of x. So therefore the point is first abscissa, then the ordinate. We got the point. Now apply it. So I will say distance AB is equal to x2 minus x1 square, y2 minus y1 square under the root. So distance is root 10. Getting this root on the other side becomes square. So straight away life is easy. Now I can consider anything as x2. Always take the variables first. That's my advice. So x minus 4 square and 2x minus 3 square. Come on, pause the video and try to get this on your own. So this is going to be 100 x square plus 16 minus 8x. Have I done this correct? A square b square 2ab. Correct. A square b square 3 2s are 6 2s are 12x. Am I right? 2 2s are 4 3s are 12. Perfect. So x and 4 will give me 5x square. Minus 8 minus 12 will give me minus 20. 9 plus 16 is 25. 100 coming on this side, so negative 75. Dividing by 5, so x square 4x minus 25. Now we'll have to split the middle term and see how we can work it out. So x square for 25, what can I take? It is only 5 5s are. So 1, 4 and 5, not 25. I'm wrong over here. This is going to be 15. Yeah, 5 15s are. So for 15 and 4, what a lovely error we've done. See, from this we all should learn. Root of 10 square will be 10, but I wrote 100. That's where we went wrong. So if this is 10, alright, 25 minus 10 will give us over here only minus 15, and minus 15 by 3 will give us, by 5 will give us 3. Now we need to split the middle term. So it is x square minus 4x minus 3 equals 0. So if I split the middle term, it will be x square minus 3 minus x minus 3 equals 0. Yeah, once we reach here, your final answer will be x minus 3, x minus 1, 0. So x becomes 3 or x becomes 1. Now this is not your final answer because you need to get the answer in terms of a. So for a, if x is 3, then this will be double of 3, so 6, or a can be if x is 1, so double of that will be 2. So our final answers are going to be a is 3 by 6 or a is 1 by 2. I'm very sorry, I made a small mistake here and that costed us a lot of time. Let's be more focused. Come on, everybody with me. How many of you are racing? Come on, try it. I'm 100% sure you will get it. Just use little brains. If you don't get, come back. I'll give you the start. Then you can go ahead. Point on x-axis. So x-axis will be x comma 0. Equidistant from these 2 points. That means this point has a distance equal from these two. So let's call this as A, B and C. So distance of AC is equal to the distance of BC. Are you getting this? This point is equidistant from A and B. That means distance AC equals distance AB. So if I square both of them, why am I squaring it? So when I apply distance formula, the root disappears straight away. So let's apply the formula for AC first. So it's going to be x2 minus x1 square, y2 minus y1 square. Likewise over here also x2 minus x1 square, y2 minus y1 square. Everything under the root, the whole square. This also under the root, the whole square. Let's apply it for AC, A and C. Always take x as the first variable, okay? So x2 minus x1, x minus 7 square plus y2 minus y1. So what is my y2 in this case? 0 minus 6, the whole square. Likewise over here for BC now. So x minus minus 3 equals to x minus minus 3. See, x minus minus 3. So directly writing plus 3. And y2 is 0 minus 4, the whole square. The roots have disappeared because they have been squared on both sides. So apply the formula here, a square plus b square minus 2ab and 6 will be 36. Again x square plus 9 and 6x. This is going to be 16. Alright. We are lucky x square getting cancelled. So minus 14 minus 6. I am pushing 14 on the other side. So that will become 20. 9 plus 16 is 25. And 49 plus 36, 40, 70, 85. So this is going to be 85 minus 25. So the difference is going to be 60 equals to 2x. So on dividing, obviously x is going to be 3. What is your target? The point. So you'll say therefore point is equal to x comma 3, that is 3 comma 0. Instead of x, what are you putting now over here is 3. So 3, 0 is the point equidistant from these two. So when they say equidistant, you can apply two formulae together. Again, a very important question from exam point of view. So please see to it you practice it well and you should get this. Is that clear? Let's go with the next one. I want everyone to try sum number 10. Read it. 100% you will get it. Go step by step. I'm pretty confident for you. So point P lies on x axis. So what will be the coordinates? Perfect. That is x comma 0. Point Q is lying on the y axis. So 0 comma y. At least this much we know. Now they say write the ordinate of P. Ordinate of P is 0. So you say ordinate of P is 0. Abscissa of Q. So abscissa of Q is also 0. Two questions attempted. Now if abscissa of P is minus 12, so therefore P will be what? See, abscissa is x, which is minus 12. We know ordinate is 0. And ordinate of Q is minus 16. So ordinate is minus 16. So it will become 0 comma minus 16. You should know what is ordinate, what is abscissa. Abscissa is x, ordinate is y. Clear? Now that you know these two, they say calculate the distance of PQ. How simple question is this? It only looks big and dangerous, but it is not. Just like me. Stop laughing. Come on, start applying. x2 minus x1 square, y2 minus y1 square under the root. So PQ is distance what we are trying to calculate. So x2, I am taking it as 0, minus minus 12, so plus 12 it becomes. Y2 is minus 16 minus 0 the whole square under the root. So 12 square 144, 16 square 256, total will be 400 and root of 400 is 20. So therefore distance PQ is 20 units. Did you manage to get this, everybody? Is it simple? Are you able to get a good hand on this chapter by now? Sum number 12, let's try it. In this question they say prove that PQRS, this is not A, sorry, PQRS is a rectangle. So if you draw PQRS as a rectangle and then you work it out. So obviously opposite sides you'll have to prove them equal. So let's draw PQRS first. P, Q, R and S. See to it you put it in proper line, okay? So P is 0 minus 4, Q is 6 by 2, R is 3 by 5 and S is minus 3 by minus 1. That's your coordinates. Now if you want to prove this as a rectangle, how many times are you going to apply distance formula? 6 times. First to prove opposite sides equal, so 4 sides. If opposite sides equal becomes a parallelogram. Then two diagonals equal. If two diagonals also are equal, it becomes a rectangle then. So let's hit it, come on. So first one, distance PQ. So if you are finding distance PQ, P and Q, so 6 minus 0 square plus 2 minus minus 4, so 2 plus 4 square under the root. So that will be 6 square 36 plus 6 square again 36. So I shall get this as root 72. Did you get the same? Yeah, that means you've paused your video and you're copying. Cheaters. Come on, go ahead. RS. So this time for R and S. So I will get 3 plus 3 square and 5 plus 1 square under the root. So 3 plus 3 6. So again 36. 5 plus 1 6. So again 36. So that again becomes root 72. So therefore I can say distance PQ is equal to distance RS. So we at least managed to prove that one pair of opposite sides are equal. Let's go ahead, this time these two sides. So PS first. P and S first and last. So 0 plus 3 square and minus 1 plus 4. Sorry, minus 4 plus 1. 0 plus 3 minus 1 plus 1. Correct. Under the root. So this will become 9. This will also become 9. So I will get root of 18. Am I correct? Let me recheck. PS is this side. Yeah. Then the next one, distance QR. So Q and R, 6 minus 3 square plus 2 minus 5 square. So 6 minus 3 is 3 square, 9, and again 3 square, so 9. So I get root 18, and therefore we can say distance PS equals to distance QR. So we managed to get the other two sides, opposite sides, equal. Now the diagonals. So PR. So PR, P and R. So 0 minus 3 square and minus 4 minus 5 square. So what will that be? 3 square under the root. 3 square 9. Minus 4 minus 5 will give me minus 9 square 81. So that will be root 90. Likewise distance QS. So Q and S, 6 minus plus 3 and 2 plus 1. See, we are using this minus as plus because of the formula. So 9 square 81, again 9, so I get root 90. So therefore distance PR is equal to distance QS. And then you say the last line, since opposite sides are equal and diagonals are equal, therefore quadrilateral PQRS is a rectangle. Do you understand how to go about it now? So 6 times we happen to apply distance formula here, and we proved that this particular thing is a rectangle. Same thing you'll have to do it for a square. If they ask you to prove it as a square, all 4 sides will be equal in that case and diagonals will be equal. Are you getting it? So now square, rectangle, all this should not be a problem for you. Let's try one more, sum number 13, a slightly different and a logical question. ABC have been given to you. So diagram for ABC. A is 1 by minus 3, B is minus 3 by 0, and C is 4 by 1. They say prove that this is a right angle triangle. Now we do not know whether B is right angle, A is right angle, or C is right angle. And not only that, but isosceles also. So what you must first do is find the distance of all 3 sides to prove it as an isosceles. Then we'll talk about right angle, how to go about, don't worry. So first one, distance AB, these two, A and B. So I'll get 1 plus 3 square and minus 3 plus 0 square. So that will be 1 plus 3 square is 16, under the root I forgot, 16, and 3 will be 9. So that is going to be root of 25, or you can say 5. Then distance BC, these two. So that is going to be minus 3 minus 4 square, minus 3 minus 4 square, and 0 minus 1 square under the root. So minus 7 square 49 and 1 square 1. So that also becomes root 50. Last one, distance AC. So A and C. So 4 minus 1 square and 1 plus 3 square under the root. So 4 minus 1 is 3 square 9 and 4 square 16. So I get root 25. Okay, or you can say 5. So we got these two sides equal. So you say since distance AB equals to distance AC, therefore triangle ABC is an isosceles triangle. So at least we managed to prove that it is an isosceles triangle. But how is it right angle triangle? Now we will prove it. So if you look at these two, the total of their squares will be equal to the total of this square. That's your Pythagoras theorem. So you can say AB square plus AC square is equal to root 25 the whole square plus root 25 the whole square. So that is 25 plus 25, 50. And finally BC square, that is this one, is equal to 50 root square 50. Since both are equal, so you say since AB square plus AC square is equal to BC square, therefore obviously by what? Pythagoras. This is converse. So therefore by converse of Pythagoras theorem, triangle ABC is an isosceles right angled triangle. You managed to get this now. So what is the first part? First part is that you prove isosceles by proving two sides equal, and then converse of Pythagoras to prove that it is a right angle. Did you manage to get it? Great job. 15th one, you got to prove this as a rhombus. This is damn simple. I am pretty sure everyone should manage this one. So no one waiting for me. Come on, hit it guys. Rhombus, how many times? 4 times. Only 4 sides, that's it. So let's call this as A, B, C and D. So first for AB, okay, distance AB. So minus 3 plus 5 square and 2 plus 5 square under the root. So minus 3 plus 5 will give me 2 square 4 and 7 square 49. So it should be root 53. Next one. Now all of them I should get root 53. So BC, this and this. So minus 5 minus 2 square and minus 5 plus 3 square. So minus 7 square 49 and 2 square 4. So again I will get root 53. This time distance CD, these two. So that will be 4 minus 2 square plus 4 plus 3 square. So 4 minus 2 square 4 and 7 square 49. Again root 53. And last one AD. If you cannot get this direct, draw a diagram somewhere like this. Say AB, CD. So AB we found first, then BC, then CD and finally AD. So what is AD now? This and this. So 4 plus 3 and 4 minus 2 under the root. So 4 plus 3, 7, 49 and 2 square 4. So I get root 53. Finally I'll say since AB equals BC, CD, AD, therefore quadrilateral ABCD is a rhombus. Did you get it? Brilliant. I am very proud those who've got this on their own. Good job. We will stop here. In the next video, we'll try and finish this topic with the second part. For your homework, I want you to do 1 part 3, 4, 7, 9, 11 and 14. 1 part 3, 4, 7, 9, 11 and 14. Is that clear?
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.